Good morning, everyone. Thank you for coming. So the plan is I'll talk you through a little bit of the presentation, the general topic, and the project we've been working on, and we'll have a break after, and then we'll do a little sort of practical demonstration of how the material works, basically. So to start off with, my name is Jan. My partner Anna and myself, we run Ludica Architects, and this project has been an ongoing venture that we've been carrying on, and sort of the talk is about kind of where we stand now and the general principle, but this is very much an ongoing process, basically. So the project is called Biobuilding, and starting off is the big why. What is the problem, and why have we undertaken this? So the construction industry, yeah, I think that's okay. As we know, is one of the biggest contributors to pollution, to carbon emissions worldwide, accounting to roughly 40% of CO2 emissions. And yes, in its sort of role, it requires a systemic change if we are to address of what is going on in terms of the climate emergency. And particularly, it's acute here in Iceland, where concrete buildings sort of make up to sort of 70% of the building stock, and it is about kind of the habits and the status quo and what can be changed about that. And sort of globally, the carbon pollution emanating from cement and sort of the energy that comes into it amounts to about 4 to 8% globally. And we see this in terms of kind of the prevailing methods, which obviously have the historical context, but you see how much more, for instance, here is built out of concrete. And this is not just concrete in terms of sort of structural posts and slabs, it's entire walls, it's entire shells of buildings. So it is very intensive. And within a kind of a wider perspective, it kind of begs the question, why do we continue doing so? There is something that perhaps has gone under the currents, a shortage of sand worldwide. And crucially also, it is about the sort of extractive tendencies for construction, where we're using materials, we're using resources that are non-replenishable, that cannot come back. And that having become a sort of a status quo is very problematic in the long term. It is not sustainable. Of course, we've heard about the local scenarios of whole mountains being shipped off to Germany and so on. But it begs the big question of, you know, how can this continue for so long? And it's also a big question in terms of where this kind of started. So traditionally, globally, where buildings were being built, they were mostly built from what was available locally, often within a certain radius of the locality, and hence vernacular architecture that was local, constituted what was available locally. It was only with the Industrial Revolution that this changed drastically, with cheap energy and, of course, imperialism and European colonial imperialism that sort of shifted the mindset and all of a sudden became a way to show power to a certain degree, where all of a sudden you could use materials that were available across the country, say in England or further afield, and very much sort of created this scenario onto which we're still building in terms of the globalized industry, where things are shipped across the world just because.
You think this will be the case? You think they will go and actually do this?
Hopefully not, but the tendencies are there, and in terms of the global sort of, capitalist tendencies, it is a big question. And also crucially, what the biomass of sort of human-produced materials is compared to what is on the earth. Again, just to put it into context. So around 1900s, the figure was around 3%, whereas the majority of materials produced by us are building materials. So there are, for instance, 1,100 gigatons of buildings and infrastructure, which is more the total amount of trees and shrubs, which is 900 gigatons globally. The total amount of plastic is greater than the mass of all land and sea life, just to put this into context. Another sort of point is obviously the internal environment. We spend over 90% statistically of our lives indoors. That obviously depending a little bit on the climate, but as we all know, this is particularly prescient here in Iceland with the weather. And with that comes, the problems that we are all very well aware of in Iceland and Reykjavik and wider Reykjavik in terms of the mold existence, and also crucially the sort of reliance on a kind of a hermetic capsules, living inside in capsules that are completely sealed off from the external air. It has become this sort of battle to seal what is outside from the inside. So of course, problems with moisture, with humidity, sort of contribute to the problems that come with the mold, with the mikla, but also the amount of petrochemically derived materials that are used in a typical modern building, where we have layers and layers of plastic, of membranes, of artificial, sort of synthetic insulation and plastics that obviously have their effect. And a study carried out by the European Commission as an example by the Joint Research Center in Ispra, Italy, found that indoor air can be so polluted that our health is threatened. In some cases, it was more than twice as polluted as the outdoor environment, bearing in mind emissions from diesel engines and so on. Up to 20% of Europeans suffer from asthma due to chemicals inhaled indoors. And hundreds of volatile compounds are found, some of them toxic. And this is also to consider an event of a fire, for instance. So, for instance, with the Grenfell disaster in London a few years ago, it's been noted that there's been a significant uptick in the cancer rates amongst the firemen who try to save the building and obviously the people inside. And that's something that, in terms of fire retardants, we often don't consider. So there is a building product that has a certain classification, and that's all good. But what is actually inside? And often producers will not disclose exactly what is involved, what actually goes into all these materials. And of course, the question of import. So living on this remote North Atlantic island, we know that currently we rely almost exclusively on imported materials. There isn't exact statistics that kind of demonstrate that. There is no way of proving it, but we know that it's almost everything that comes in on diesel-powered ships. And, it sort of points to two points. One is a dependence on externally produced materials and products, and a vulnerability that also comes with that in terms of, as we all seen during the COVID pandemic, during the recent wars that have erupted, be it Suez Canal, be it Ukraine, this whole system is sort of vulnerable, and very quickly we could find ourselves dependent on things that cannot, for instance, arrive or be disrupted. So, and just to put it again into context, the global carbon footprint of the shipping fleet is more than 2% globally, which is more than the annual emissions of the UK or Germany. So again, throws it into perspective. And of course, something that some of you might be aware of, but again, the tendency and sort of wastefulness that comes with the construction industry of how much is put to waste and often deposited, non-recycled, into landfill. So in 2017, just to give an example here, about 60,575 tons on construction waste was generated in Iceland, 65% of which were minerals. And again, coming back to what the building products are made of, a lot of them are non-recyclable. They're made of composite materials that are very difficult to extract and break down in order to be reused. And this applies to the plastics as well as glue that comes into sort of sandwich panels or COT elements. So it's not just the kind of the obvious choices where the petrochemically derived materials, but also those that seem at the surface to be quite sustainable and good, but because of how they're put together, make them impossible to be reused.
This 64% it's a new number.
It's yes. So this is from 2017, basically.
17.
Yeah. So relatively new. And before kind of looking towards the potential future, it's always useful to look into the past as to what things were made out of and how they were made not that long ago. Of course, Iceland has its unique history, and the Industrial Revolution came quite late here. But of course, we had the turf houses that served the population here well for hundreds of years and were made exclusively from local materials. We have examples of that across Scandinavia in different forms and shapes. But crucially, again, it goes back to this idea of vernacular. Regardless of where we are in the world, sort of building methods and sort of architectures and designs have evolved in response to the local climate, where there was no air conditioning, where there was no mechanical ventilation, and sort of served the sort of prerequisite requirements for each climate. And the change that kind of came sort of early on in the 20th century, in the case of Iceland after the great fire of Reykjavik in 1915, and the very quick transformation that we saw from timber construction to concrete, which became the standard bearer, the norm, happened very quickly. And the same can be said for many other countries. So for instance, where I partially come from, Egypt, the traditional architecture was either stone or mud brick, and it was designed to facilitate passive ventilation, to keep the buildings cool during very hot days, and vice versa during the night, where the thermal mass would sort of radiate and keep a healthy environment without reliance on all these complicated modern systems. And with the sort of onset of concrete, very quickly you found buildings that were, almost uninhabitable without fans, without air conditioning, because of the properties of concrete. But again, that was seen as new and modern, and therefore the old was discarded and not seen as appealing anymore. So that's one example, and it very much can be said about the turf houses. Of course, it was a different time historically, but there's so much that can be learned from this approach of using what is available and, crucially, what is not extractive, so what can be replenished. So coming to the topic of this talk, is the question of bio-derived building materials, of which there is sort of increasing, although very small amounts and very sort of scattered across the world. But it's been around as a technology for, again, very long. It's been used in many cases, across Europe, across the whole world, really. But it's as a kind of a concept, not really forming part of the mainstream. The crucial element is it can be used in many ways, and there's many examples. But what it can be used and what it can do as a carbon sink, crucially. So, in the case of hemp, it absorbs a lot of carbon throughout the year, and it's a sustainable, so sort of recurrent annual crop. So once harvested, it can be grown again. And the same can apply to many different materials, be it reeds, be it straw, sort of seasonal crops, plant-based, that can be turned into endless amounts of things, but also building materials. If I skip on to the next one. So we, as part of our kind of ongoing research, we've been looking at many different materials, but hemp sort of stood out as very potentially interesting for Iceland because of its sort of good building properties, and the fact that it can be grown here, and the fact that it is, again, can be used in a way that does not become extractive. So it can be used, for instance, as a break crop. So it doesn't need to sort of exclusively take over farmland to be just used for the purpose. It can be used by farmers in between different crops. And in the process, it also fertilizes the ground itself. In terms of the uses for the material, we've got, so this is a cross-section of a stem. So industrial hemp has to be noted that it hasn't got any psychoactive properties, therefore it can be legally grown here. So the internal stalk, the treni, or the shiv, as it's often referred to, is the key component for hempcrete. And you can see it here. This is a sort of a sample block showing how it's constituted. The external element, which are the fibers, can be used and have been used in rope making and textiles. It can be also used to make bioplastics. There's endless uses that can be applied to. And in warmer climates, it can grow up to 4 meters over a course of 3 months. In Iceland, and to our experience with our test crop a couple years ago, they easily reach 2 meters in height. So from a harvest period of sort of early June till sort of late August, September, they grow 2 meters in height. Now, in terms of its applications, it's very simple. I mean, it consists of the sort of shredded shiv, which you can see here, a glue, a binder, which in this case is a mix of hydraulic and hydrated lime, and water. So it's a very simple material in terms of its components. It can be used in walls, it can be used in roofs, it can be used to insulate floor plates, both ground-bearing and internal. And it crucially can be used in a retrofitting sort of scenario. So you can take existing buildings and fit them in with this material. And it's very versatile in terms of the ways that it can be applied. So it can be poured on site in situ, effectively using formwork similar to concrete, where you create the molds basically, and then layer by layer you fill it in. And that's the kind of low tech, if you like. So it can be used by sort of self-builders, more experimental projects, yes, I mean it doesn't really require much. The one element or the factor to bear in mind is it is not structural, so it can carry its own weights. It's quite good in its tensile strength, so it's kind of a little bit stretchy, so it can work well within sort of earthquake-prone environments, for instance. But it hasn't got the compressive strength of a structural material. So typically you need a frame to carry the building itself, and the hempcrete kind of goes around that frame. Typically that is timber, but it can be whatever. So we often get asked this question as to, what is the limit to the height? Well, the limit to the height is as high as the structure can go. Be it, 10 stories or more, there is no limit to it as such. Of course, with it comes the detailing and how it exactly sits, but it is quite versatile. Now, in terms of sort of more cases where you need sort of the efficiency and speed of construction, as well as being less dependent on the climatic kind of conditions, it can be prefabricated to make blocks, which you can then sort of build up on site, as well as cassettes, where whole panels can be prefabricated in factory conditions and controlled environment, and then assembled together on site. In terms of its key properties, obviously it's a very good insulator. It has thermal mass, again, what I mentioned earlier, so it stores heat and releases it slowly, which often a sort of a parameter that's often not captured by sort of insulation materials, where you've got a certain thermal conductivity rating, but that sort of action is not captured. So for instance, compared to stone mineral wool, which is not very dense, yes, it is insulating, but it hasn't got this heat storage capacity. It is breathable, which is another very, very important component. So it is diffusion open. So it is, again, depending on the exact scenario, but it is sealed in terms of airtightness, but it breathes. So it releases the moisture and the heat and sort of regulates the internal environment accordingly. And crucially, because of that and because of the lime properties, it is not susceptible to mold growth if done correctly. It is a big carbon sink, so as the plants themselves bind carbon during the period when they grow, but crucially, because of the carbonization that happens and a process that happens when it is actually set, it continues to absorb carbon as a building material already. It is fireproof because of the lime content, so it sort of serves there's been experiments and tests carried on different kind of mixtures that demonstrate that it's non-flammable. Basically, it doesn't carry, it doesn't sort of burn. It chars a little bit, but it doesn't sort of carry the flames.
Can I ask?
Yes, of course.
Is it lime content? No.
Lime.
Lime.
Yeah. Calc.
Yeah, lime.
Yeah.
Ah, okay. And that's why it doesn't burn.
That's why it doesn't burn. Exactly.
So it holds like for 60 minutes or?
Yeah.
Ah, yeah, okay.
Yeah. So it's and again, because it's still an emerging material, like there isn't a kind of a unified certification sort of system, but it has been proven that, to be highly fire resistant. So it hasn't got like a 60 IE rating as such yet, but that's kind of part of the process and what we are also trying to do as part of a wider sort of network to.
So it's similar to stone wool?
Yes, in that sense. Yeah, but basically because of the lime content.
Also when it comes to acoustics?
Yes, so it's very, it's a very good sort of acoustic insulator, attenuator, but also crucially, not just in terms of the transmission of the sound, but also in terms of the quality of the sound. So I'll talk about that a little bit more later, but the little prototype that we did, that was one of the nice surprises that we found, that you could have a storm raging outside, and in a normal kind of timber, lightly insulated building, you feel kind of what's going outside. With a hempcrete building, it's boom, it's like a capsule, basically. It really, really holds it out. But because of its surface area, it creates, a good dampened environment acoustically as well. And crucially, it is a circular product. So at the end of its life, if need be, it can literally be broken down into the earth and it will compost. It will sort of go back into it. Because, yeah, all the sort of ingredients in it are natural. In terms of its history, so again, in terms of, there is some evidence or sort of stories that it has been used for a very long time. So it's been sort of found on archaeological sites, but in its modern sort of form, hempcrete started in France in 1980s, where it was used or initially used as in conservation of historic buildings, basically because of its breathability and because they found for it to work really well in such cases. And just to sort of point out one thing, so here on the right-hand side, you see it in a spray form, which I didn't mention. So it can be sprayed as well as being prefabricated and sort of cast inside. So you need kind of special machines for it that have to be adapted. But it is, and it needs sort of a high amount of skill and specialization for the people that do it. But it can be a very efficient and quick method.
Like mortar spray, like spraying with mortar?
Yes, exactly. But it needs to be adapted because of the size of the particles and things like that. But it's the same principle. Yeah. So you need to mix it first, and then.
How long does it take to set?
So it's very quick to set in terms of staying in place. So for instance, with where you kind of cast it, it's sort of good practice to leave it for 12 hours. But we know that by taking the boards off immediately, it's already staying in place. It's the drying that takes longer. So it sets quicker than concrete, for instance, but it takes longer to dry, basically. But because it's, again, breathable and provided the materials that are used with it are breathable as well, then it sort of follows its natural cycle. But sort of typically you would want to leave a building cast in situ, for instance, to stay for about 4 to 8 weeks before you start finishing it. So, of course, if it's done in a factory setting and pre-dried, then it's a different story. But yeah, that sort of timeline. No, it can also be done externally. Yeah, so I mean, of course, you need to have some sort of a cover, but yeah, it kind of then replaces the need for molding, for creating molds and the shuttering, basically. So it's both internal and external.
And you can do it like in more thicknesses, right? You don't have it's not only like a 5 centimeter.
Yeah. It can be exactly. I mean. Depending on how thick the wall and how insulated you want it to be. Exactly.
Has it been used in Iceland?
Yeah, what, the spraying or hempcrete? The spraying, no, not yet. So we, one of our collaborators, he's a specialist in that in Britain, basically, and he's done a lot of that. But you need those special machines, basically. So it'll take you a little bit more on the journey, but that is to come later. And it also, bearing in mind, the local climatic conditions, the freeze and fall, the fact of what is the sort of ambient temperature here and so on. So here are a few examples of buildings across the world where hempcrete has been used. So sort of the top two left pictures is a residential development in England, which is, I think, about 10 or more years old now. So here you see a kind of a timber-clad facade, as well as a Moorhoof rendered finish. The top two right pictures is a building, quite a recent one from the last few years in Paris. Here, the structure is concrete. So you see the slabs and the posts, and all the external walls are done with hempcrete. Bottom left is a retrofit project of I think it was an office tower turned into residential accommodation in Johannesburg, South Africa, over 10 stories. Middle bottom is a filmmaker studio in England, and this was done using the cassettes that I described earlier. So kind of in a prefabricated sort of scenario where they came as panels and were done, and the cladding here is also from the fibers, basically, and it was sort of pressed with natural resins to create this sort of corrugated cladding, also from hemp, from the plant. And bottom right is an ongoing project in northern Bavaria, if I remember correctly, which is a sort of, again, an experimental project for kind of like a eco-retreat / community center, using traditional German building techniques, but also using hempcrete in a slightly different composition than we have been doing here. So we've been in touch with the people who are running this project. But crucially, it is kind of the first of its kind in Germany, aiming again to sort of showcase that, you know, it is a workable material, and it's a sort of collaboration between the local municipality, universities, and craftspeople, basically. But it is a...
I have one question.
Yeah.
About the Paris project,
Mm-hmm.
I can see it's done on the left-hand side.
Yes.
Window. Was it like in situ, or was it element? Because most of it is windows.
No, so these were, I think, sandwich elements which were prefabricated.
Yeah.
Yeah, and then windows were installed later, but yeah.
So no structural elements in the hempcrete?
No.
Because it's concrete, or
Exactly, yeah.
solid concrete?
Yeah.
Hempcrete.
So exactly. And again, so sort of what the beauty of the material is that it can be a sort of a mono material. So, you know, you literally have a wall, you have, you know, this sort of material all the way through. But it can also be used sort of in a sandwich or sort of, you know, composite. So for instance, you can have insulation, and then you can sort of work to reduce the thickness of the wall slightly, basically, where you have sort of solid hempcrete like this, and then hemp fiber insulation. So in its, and you know, we believe that the beauty of it is in its simplicity, but it can also be sort of adapted to more, you know, modern or slightly more complicated ways in terms of how it's.
But do you know how they put the windows in, and how the detail around the window?
Yeah, I mean, it's like with any.
There's nothing else than just hempcrete.
No, so I mean, you would leave a timber frame,
Yeah,
kind of.
in the
Yeah, exactly, and that would be your structural opening, and then you would fix to that. Yeah, and in terms of sort of detailing, you know, you still have the waterproofing running around the edges of the hempcrete, basically. Yes, so moving on to our ongoing project here. So it kind of was born when we moved to Iceland from London, and in 2020, and kind of we've been, you know, coming and going. My wife is Icelandic, obviously, but it was sort of born, yes, out of a sort of a fresh, fresh perspective when we kind of saw after many years in London how, you know, what the construction industry was like here, and what was kind of the prevailing methods and ways of doing, and we saw a massive potential for hempcrete that could be used here. So we set off, aided by a number of grants, to initially design and build a prototype that can be used then as a testing ground and as a demonstration of it being suitable and workable in the Icelandic conditions. Because very often you get the question that, great, you know, it is a great material, but will it work here? What about the freeze and fall? What about the dryness? What about the wind and so on? And we knew at the time that it had been grown here. Yes.
Earthquakes. Sorry for the
And earthquakes. So because of its tensile properties, it's quite good in that sense, in terms of kind of movement. Of course, you get a massive earthquake, everything will move, but particularly in combination with sort of timber buildings, because of its stretchiness, it has the properties that, you know, should work well. Yes, so we knew that hemp had been grown here, sort of on a more amateurish scale, but we saw evidence that it is possible. So initially, our plan was to kind of do it all self-handedly and to grow at least part of the hemp here locally to build from. So we planted a hectare in Sandhóll in South Iceland in 2022, which, despite a rather cold summer that we had back then, grew really well. Sort of considering local conditions. So we had sort of an average of sort of 1.9 meters. Some of them were higher, some of them were a bit lower, but it was a decent crop. We're quite sort of pleasantly surprised with that. Unfortunately, we didn't get to use that to build our prototype because you need specialized machinery. And it turned out that kind of the machine that was sort of available that we borrowed wasn't sort of really suitable for even a small scale, but a kind of larger, it just wasn't, it was mostly used for the fibers, as well as a bit of a kind of miscommunication with the farmer. So it wasn't picked up in time, basically. And then a lot of the harvest was basically left over the winter, and then it just rotted. But it was more kind of a test for ourselves to see whether it can happen. And again, that's part of our ongoing work. We're hopefully going to get further grants to then more systematically test it in collaboration with the Agriculture University here. Yes.
You said that this was grown then from early June to late August.
Yes, exactly. It was even in September that we harvested it. So it was just before the...
in Iceland, we only have that window. Like it can't be...
Yeah.
Need to go inside.
Then it would need to go inside, exactly. And again, it's kind of, volatile every summer, as we know, is different. It depends on where you are in the country. So that, hopefully, fingers crossed, will be kind of the next investigation to see how it grows in different parts of the country, again, to statistically analyze it.
But we only have like this one harvest.
One harvest a year, yeah. That's the kind of the reality. As it stands. Obviously, with internal growing, it's a totally different story, and then we're talking much bigger. But yeah, in terms of a kind of a low tech kind of approach, that's the reality. And again, hopefully, out of our kind of investigation and the ongoing project, we'll get much more solid numbers to actually see what would the yield be, and how much land would then be used. But in theory, based on our kind of initial research in terms of the available arable land, it should be possible in terms of a wider scale application.
Can I ask you, is that it needs special machinery for processing? Is that something that's not available in Iceland?
No, not yet. So it's not very complicated machinery, but to do it at a wider scale, yeah, it needs basically a machine that kind of breaks away the fibers from the sheave, basically, and there isn't that equipment here yet. So it is a kind of a bigger investment. You can do it at a smaller scale, but then obviously, if we're talking about wider, more commercial application, commercial in a sense of it being used on not just kind of cottage industry, individual projects, then this.
Is it machinery used in agriculture otherwise?
No, so it's more specialized in that sense. But sort of typically, it's it's used more than in a sense that hemp has many applications. So, for instance, in Britain, there's like mattress makers that use the fibers, and then this is really kind of the byproducts. So the fibers are much more valuable, and can be used in many sort of different applications in bioplastics. So apparently BMW use it somewhere, and it's already kind of being applied. But the sheave itself is a byproduct almost. So it's in that sense, yes, it can be used for different applications, but not really. There isn't as not such a specific requirement for other agricultural uses for that part of the process. And then since sort of setting off on this journey of ours, we have carried out a few workshops where our sort of key advisor, Tom Woolley, who you can see in the picture in the middle there, who was one of the, in a way, vanguards, pioneers of kind of natural building materials, who sort of started way ahead of the curve, was our mentor to begin with, and he has ample experience with this material and others. Yes, there's always been sort of keen interest in hempcrete in Iceland, which is very encouraging. In terms of our prototype, we sort of set ourselves kind of key parameters. So it had to be small, and because the current building regulations do not sort of facilitate yet using more kind of innovative techniques or sort of untested techniques that don't come with certification on a wider scale, we set out to do a smáhýsi, which does not need sort of building planning permission as such, so no higher than 2.5 meters and 15 square meters footprint. And an approach to use, obviously, as much natural materials as possible and with a light kind of touch. And we set off again on a family sort of plot in Grímsnes, where, yes, the climate is sort of reasonably sheltered, but that was kind of the starting point. For it to be raised off the ground and not sort of use, again, a slab kind of scenario where we had to pour lots of concrete and cement, but to use kind of prefabricated footings, to use as much local natural materials, so sourcing everything that we possibly could from Iceland, relying as little as possible on imported materials, and kind of architecturally using the concept of a tea house, basically. So a little sort of standalone building inspired by this Japanese approach of a kind of small, humble building, a kind of a space for contemplation, but also a multi-purpose use. So another studio, another bedroom, a workshop, and so on. So we sourced the timber from the east of Iceland using poplar. I forgot the name in Icelandic. Nei, ekki fura, that's pine. Poplar. It's sort of the very fast-growing.
It's a high tree.
Yes. Osp, nákvæmlega, yeah. Which hasn't really been done before, but to use it both structurally as well as for all the cladding, or sort of like the timber deck and the underside to the roof, to the canopy, and lerki, larch, from the north of Iceland, nearby Akureyri, using these kind of shingles. And again, sort of architecturally, the concept was for this tea house. So again, taking cue from Japanese tea houses, the door is quite small. So as you enter, you bow down and you leave all your ego behind, and you sort of enter this space, and all of it being kind of orientated to frame the views. So looking towards Ingolfsfjall with the wider window, and the little sort of forest to the west of the site, and very low tech. So just having a simple kamina, a simple sort of wooden stove as the kind of heat source. But again, crucially to see how the building would behave, not in a scenario where it's constantly heated, but to be able to monitor what happens when you completely let it go, and when you heat it, and how it behaves, and so on. So here for the sort of landscaping, we use rauðamjöl, also nearby. Hrossafari for the sort of screens. So again, we're inspired by the shoji screens that you have typically in sort of Japanese architecture, these kind of sliding rice paper screens, but we wanted to see whether we could use local seaweed for that. So I'll tell a bit more about that. The timber, the cladding. We used a little bit of steinutl in the roof, again, for one, to see how it works in combination with a material that's already locally available, but crucially because we're limited in terms of height. So in order to get that much thermal sort of performance from the roof, we would have had to have a much much. A little bit taller, and of course we're limited to the constraints. And crucially, these prefabricated footings from nearby Keflavik, Íslenskhús, I think they're called, which were the foundations, basically.
What was the Rauðamjöl?
Reifamjöl, that's just for the sort of landscaping around. Yeah, so it's, funnily enough, apparently it's used a lot in Norway for green roofs, so it's actually, there's a little sort of mini market for that, so it gets exported quite a lot. But in our case, it was just a kind of landscaping element, so more of a kind of design approach.
They used the Rauðamjöl for the roofs?
Yes, apparently. So they use it as a substrate before they put on the turf, basically, because it's quite porous and quite light. So for some reason, yeah, they discovered it somehow and found it to be well used. So a lot of this Rauðamjöl that's kind of mined locally goes to Norway, apparently.
But the lime, that's always imported.
At the moment, yes. And again, this, so...
But we exported a lot.
Lime.
There's like a car factory.
Yes, exactly. I mean, but this is from the calcified seaweed. Yeah. Exactly. And this is, so it's used for like food additives and... It has found. Yeah. And so again, that's something that we're looking into. But yeah, it's sort of used, so it gets exported to Saudi Arabia and places like that a lot. And but kind of our question is, how sustainable is it? So basically, I mean, they've got kind of these. So I think they started. I think they're moving up to close to Ísafjörður, but basically, yeah, they sort of scoop up this calcified seaweeds, and apparently it is kind of sustainable. But for instance, like in the case of England, this was completely depleted, I think, in the course of 19th century. So they used to have a lot of it, but now there's none. And of course, it takes a long time to grow back. But yeah, coming back to this, lime needs to be imported. And that's something that, again, we're looking into as to what can be sourced locally at the moment. But at the moment, it is an important component of the mix. Yeah, so to jump into the process of building, sort of bearing in mind the nature of the project and the general ethos, we thought to reach out to people who are called Wandergesellen, who are traveling journeymen or craftsmen, journeying craftsmen, whom my old friend used to be one, and I've known him for ages, and we thought, great, this could be an excellent opportunity. So he reached out to some of his brothers, and 3 of his brothers turned up. So we have Elias, Basti, and Georg here, standing in top of our rooftop studio in Guvunes here. And they are, it's an ancient tradition, so it dates back from sort of medieval guilds where craftsmen, upon completing their apprenticeship, would set out on a journey that would be 3 years and 1 day, so 1 day longer minimum than their apprenticeship, with view of meeting other cultures, learning their craft, applying their craft, and expanding their minds. So this sort of, existed in medieval Europe, but it kind of was reincarnated in kind of late 19th, early 20th century. And to this day, they continue to do so. So they have different schachts, so different associations. And in this case, it's 2 carpenters and a joiner. But they can also be, bread makers, they can be jewelers, blacksmiths, brewers, you name it. And they come with fantastic traditions. So they have their clothes that they wear, so they can basically travel only in their, basically have a little bag that you see on the left here with a walking stick and their hat, and they only have 1 set of clothes to change in which they work. And in theory, they work for shelter and food and travel, basically, and they just go around the world. And yeah, they have many, many great traditions, and it was a total joy to work with these young men, both spanning kind of the traditions and their great knowledgeability about their craft, as well as kind of considering, differences between Germany and other places in Europe, and here the status of the construction industry, their experience, our experience, and musing on the future. And so they knew what the project was about, and they were quite excited. And to begin with, they had no idea about hempcrete. But by total coincidence, one of them, just before coming here, worked at the German project that I showed you earlier. And so this sort of started another kind of connection, and was very interesting in terms of what they used there and how differently they approached. So for instance, they used quick lime as opposed to this hydrated lime, which is, so it's the lime that kind of, when you add water, it heats up basically. So, and it dries much quicker. So you have to, the sort of process of casting the walls has to be much more rapid, but it sets and dries quicker as a result. And it has a slightly different kind of, not molecular, but the capillary structures in terms of the sort of air channels that are created in the lime are slightly different to this method. So this is what, again, they're experimenting with in this project in Bernau. Yes, the project went quite smoothly to begin with. They really know what they're doing, and in terms of timber, but they were very open-minded to adapting to kind of new ways of working and methodologies that we're kind of using. So here you can see the floor deck being constructed, and we had the hempcrete laid in between the joists over there, and where we did it kind of in 2 layers in order for it to dry faster. So we set a thin layer to begin with, let that dry for a little bit, and then put the second one in.
You just have a timber board underneath.
Yeah, so we had timber boards, but we also had obviously a mesh for mice and a geotextile fabric to kind of hold it in, and then a layer of lime and sand at the bottom to create the weatherproof or the airtightness layer, basically. So that's kind of sealed it off in terms of air robbery, as we call it, but also allowed for breathability, which is the crucial component. So you never seal off the buildup.
Is this USP?
This is USP. So you see they're apart from a few of the timber beams, which are limtre, glulam, which just basically because of the spans and because we had this long overhang. But yeah, the rest is USP. And as often in Iceland, it was not as much a question of creating a grounding as making sure that the building doesn't fly off. So in terms of the footings and how that was done, and obviously kind of the connection details on it. And the tradition of these guys is upon completion of the main structure fair, which we have also here in Iceland. There is a little sort of party to celebrate that the structure is in place, and they recite poems and drink champagne and break a glass to mark the occasion. And once the frame was in, we set upon casting of the walls. We were lucky to have a very good summer last year, so starting sort of from July. So we had good weather, and again, it's a very small building, and we're all doing it kind of for the first time with sort of advice from the experts and our connections in the UK. But very quickly we found a good way and a good sort of rhythm to the whole process. So even though this is the low tech and the kind of the slower methods, a building of that size can easily, once you know what you're doing and kind of set the rhythm in place, can be done in a week. It's not an issue. So it was a question of, we had a simple kind of concrete mixer here, but typically what you would want, especially for kind of larger projects, if you're doing this method, is to have this kind of a flat one that's often used kind of in agricultural settings. So that you have a big sort of pan that kind of revolves, and then you open it from the bottom, and you have the ready mix that you can take in, and kind of creates this process. Yes, it's sort of it's key to to kind of delegate sort of the different roles quite well, and also to keep consistency. So even though it's it's a very simple method and a simple material, there's key elements that you need to get right. There's key detailing that you need to think about, and also strike a balance in terms of how the material is sort of compressed. So you kind of you tap it down to consolidate, but you don't want it too dense, because obviously then it loses its thermal sort of insulative properties. But then around the edges and around the different details, you need to be more rigid and so on. So it kind of you strike a balance. And I mean the process went well. Working with lime is you need to take some sort of precautions. It is an abrasive material, so you want to kind of wear a mask and cover your hands and gloves. I wouldn't call it the most pleasant of techniques, but you can argue any sort of building trades has its pros and cons. There was some sort of learning along the way. So there was a mistake in the mixing proportions, and they coming from the manufacturer. So one of the walls became too dry, and we had to kind of fix it. So partially kind of open it up and fix it up, but eventually it still worked well. And crucially, I'll show you in a second, the performance seems to be good as well. So here you can see the sort of finished walls. On the northern side, so this is, on the sort of eastern side, we had the cladding. So here we set the joists to the outside so that we could fix the battens to them. Whereas on the other three walls, where we're going to render, the joist sets sort of centrally within the walls, basically. So, there's some sort of thinking that you need to do in terms of planning. So here, I don't know if you can see so over here you have it's set kind of on the inside, and here you can see the joists are set to the outside of the wall, with the wall but kind of being mostly internally. Yes, and here on the left-hand side, we again sealed it. So we sealed it with kind of like a lime wash, so as opposed to using a breather membrane to create, so to take away again the plastics. We use this as a sealant, which then prevents the air going out, but is still open in terms of diffusion.
Is it a 30 centimeter wall?
Yeah.
What?
35.
35.
35. Yeah.
You choose it for the insulation.
We chose that for the insulation, exactly. Yeah, exactly. So here you can see some photos of how it looks inside. This is not fully finished, so we purposely left it mostly exposed internally over the course of the winter. And that's a carpet. So it's a natural wool carpet, so again, breathable and quite a thick one, so it's because we're so limited in terms of all the dimensions, it gives this extra bit of insulation. And so we left on purpose the building internally kind of unfinished, so that it had the whole sort of winter season to kind of settle. And again, back in the Gamla dagar, in the old days, that's what you would do with timber structures. So for instance, in Germany, you typically would build a house, let that sit for half a year, let all the wood settle, everything move down, and then you would finish it once it kind of sat in its place. And we did the same thing externally. So we only had one wall covered fully in the render. The other ones we just put a light coat, and now in the summer we'll sort of finish it off fully. Here you can see the fare screens, which we did in collaboration with Alberte Johansen.
Albert or Alberta?
Alberte, yeah. And they turn out beautiful. So you kind of see a little glimpse here, but they kind of created this almost like stained glass effect. And funnily enough, the different coloring comes from the periods when it's harvested. So if it's harvested later in the year, it turns much redder and turns more kind of brittle, funnily enough, and thicker.
Seaweed.
And that's the seaweed. Yeah, exactly. So, this is purely kind of an internal fitting, more sort of internal design fit out. It's not, doesn't...
And how was it processed? This is any machinery to stretch it?
No, so this was all by hand. I'll show you in a second. It's basically, you kind of, you mix it and you create these sort of thin plates that then dry out. And then basically we just kind of stretched it around, cut out around each piece, and then put the framework around. And we've got some images later on. And it's sort of, a tiny little project, but we kind of tried to celebrate the craftsmanship involved as much as possible, all the little different details and touches, thanks to the amazing guys they're working with. So here you see Bashti in the joinery workshop doing all the different screens. With love and passion, he approached his work, and we're extremely happy and very much a collaboration. So we worked through the project very much as a team, and it was a joy to see. And everything is still standing and acting well. And here you can see the screens. So you see they were dried off in sort of different patches. You can see the different colors, and then basically patched into the screens themselves.
How much of this was like actually designed and drawn out and then worked from drawings, or was it kind of like
both? So I mean, I mean, of course, we in terms of the screens and the sizing, of course, we drew all of that out. But in terms of the seaweed, that was very much an experimental process. So this was the first time something like that was done, and we sort of set with Alberta to find a way of doing it, and this is an ongoing collaboration that we have with her.
Thinking more of the journeymen, like, are they working? Of course, they're working after drawings, but like, do they like use their craftsmanship?
Absolutely, yeah. Absolutely, and we discuss every single detail, and they would have ideas, we would have ideas, and it was very much a collaborative sort of process. But also, a kind of experience for them as well. Yes, and then lastly, so this was sort of early in the fall, we applied the first coat of the Moorhoof, and this is in fact not an ancient but an old formula that was used in England in the sort of 17th century. So it's a chalk and lime mixed with fibers to stick it together, and it was discovered, funnily enough, in like an old manor somewhere in Yorkshire, if I remember right, and it was partially collapsed, and so there was one wall that was completely exposed to the elements, and they saw that this render, this Moorhoof, acted really well, or sort of survived really well. So it was kind of, the formula was sort of calibrated, and that's what we've been using for this project. So again, this is unfortunately, but an imported element.
And is it cement based?
No, it hasn't got any cement in it. No. So it's purely chalk and lime and fibers, basically, and breathable, basically. Yes, and here you see the building. So again, it's sort of the Moorhoof partially applied. It's not fully done, but the lerki and the cladding is in place. Yes, I mean, with the Moorhoof, it is a kind of a trial and error. So over the winter, the wall that we did fully, some of it crumbled away. So that's something that we'll need to kind of address. But it's also a technique that's not really that familiar maybe here. So again, it's also bringing the sort of techniques and crafts into this sort of application as well. So it is an experimental project, so we're building as we go along.
One question,
Yeah.
while we're there. was the finish around the windows? Did you just use a traditional?
Yes.
Or was it?
So basically, it's timber frames that go around, but what we did, we insulated it with, so kind of internally as you would with a normal kind of timber frame, insulation in between, and then we used Siga kind of taping around, and then put the frames in around, and then taped around the frames as well. So it's kind of like a double. No kite. No. And
so it's kind of a permeable wind.
yes, exactly, but kind of waterproofing and touch wood. So far, so good.
You don't have any other membranes. You don't have any.
No.
membranes
No.
on the exterior or
No, exactly.
jam on the inside or
No, this is it basically. Apart from the roof, obviously, because that's stain wood, but so that's more like a standard build-up with a ventilated top bids. But if we did it in hempcrete, if we had that little bit more space, then you wouldn't need to either, basically.
And what is the U value of the wall?
So the U value is, I think 0.18, if I remember right. Yeah, so it's good, it's decent, and kind of more than often you get as the building regulations here, Exactly. Exactly. And then what we're doing now over a period of a year to start off with, but we'll see is, so we've installed probes and sensors internally, externally, within the walls, within the floor as well, and monitoring its kind of behavior. So you can kind of see, and I think that it's also a fact that it is still drying a little bit, but you already see kind of the tendency. So here on the top left, you see the humidity jumping up and down, up and down, up and down, and you see the lighter blue line is the kind of internal humidity. So you can see what it kind of does. This is with minimal heating. Same thing on the bottom one. So you see the kind of orange line, which is more or less stable. This is running across the whole of April. And this is literally with a radiator set in the lowest setting. So we have kind of,
So you have constant heat.
there, yes, at the moment. But before that we didn't, and again we'll kind of turn it on. But this was just to see kind of how it kind of behaves, and so you can see the classic Icelandic freeze fall jumping up and down, and you see what happens with the heat and how it kind of stays stable.
And the floor is in the middle, right?
The floor, yes, and the floor is in the middle.
Even one.
Exactly, that's the most even one, and this one is more or less like this. And here you can see the kind of over a course of a day, basically, kind of what happens. So again, with the humidity jumping up and down, humidity internally staying sort of, just above 50 over here. And same with the heat, more or less, kind of thing. So it kind of corresponds, but, it has this sort of delay and a sort of permanence, stability to it. And this is again kind of showing.
But did you do this also over the winter?
Yes, so we installed it in February, early February, I think, and we'll run it through to next February minimum, basically. And then with this data, so this is kind of the.
It's interesting because January and February last year and this year were like extremely.
We're super cold, exactly.
For like long periods of time.
Yeah, which was quite unusual. Yeah, exactly. But the kind of so we will want to start with a year minimum and sort of possibly take it over to have this data. So obviously, and to our knowledge, something like this hasn't been done before, and that's kind of details in terms of actually putting the probes in. But we see it as a crucial sort of step in proving, okay, this building not only stands and look, it doesn't crack and it's not falling away, but like how does it actually behave? What is its performance, basically?
I'm a little bit curious about the construction side. Is it very dirty? Is there a lot of stuff in the air?
Yeah, I mean, it's not, it's like it's,
That's if you're doing it outside.
yeah, you want glasses, and you want, especially when you're mixing. So I mean, I'll do a little demonstration in a bit, but it is a powder, so it kind of rises, and particularly when you initially mix, but it's in period. So basically, once you add the lime, there is an initial sort of cloud that comes up, and you kind of want to be sort of set up on the site in a in a proper way. But once it's in, it's fine, basically, and then it's kind of this havra kroit kind of consistency where, you know, you have it and it's already wet and then it's quite malleable and it's, So, but it is a repetitive job. So, and again, because we're doing it, you know, kind of small scale, in this case, you know, you kind of feel it in your bag because, you know, you're kind of doing it kind of yourself. But if you have a sort of a bigger setup, for instance, with like a, you know, a circular pan kind of mixer, that would make things much easier, basically. And then you kind of, you know, you set up a sort of a, not a chain of command, but kind of like a 4-desk kind of production chain. So, you know, you mix and someone carries the buckets, puts them in, someone else is kind of in 2 different places, you know, putting it in, someone carries back, the next mix is done. So it's kind of like this, production line, basically, that happens. This is on site. So if this is done in a sort of workshop, then it becomes a completely different story. And there, for instance, you know, you could have the cassettes, for instance, if you're doing sort of these prefabricated panels, pre-made panels, then you could do it lying flat, protect it, raise it up, you know, and then it's a different story. So it kind of depends on the situation. But it is relatively messy. Yes, and so our little building is standing, and we really hope that kind of the continued sort of data that we can take from it supports the case. It is, as I mentioned at the beginning, you know, it's a tiny project, but it's a small step in a big direction. And by having it here and by sort of, you know, proving and hopefully ultimately, you know, validifying its suitability here, it could do a lot. And we know that, you know, the way building is approached needs to change drastically. It's been done once here in Iceland in terms of the transition from timber to concrete. It can be done again. And, you know, being a small country, we're nimble. We can do kind of a whole societal change quite quickly, which could, you know, show the way and lead the way, you know, for other countries to follow in, for this, you know, to really have a difference. And this, you know, hempcrete is just one example of this approach. We have to drastically reduce the pollution that emanates in our ways of being. And change is never easy. But again, in terms of using this material, these are all transferable skills. So in terms of, you know, the different trades on sites, you know, it's not rocket science. It's just a question of approach. But the biggest hurdle is mentality, how we approach it, and also the building regulations to facilitate building methods that not necessarily have CE certification at this rate, that facilitates trying new things and for the new things then to become precedents that can be then used on a wider scale. That kind of wraps this up. So please, thank you, first of all, and shoot any questions away. And I think we'll have a little break for coffee, and then we can follow up with a little demonstration so you can see the material and kind of the basic principles of how it's done.
I have one more question.
Yes.
Regarding the connection of the wall and the slab or the floor,
Mm-hmm.
was it like, how did you the solution of the cold bridge? Was it like monolithic?
Yeah, so it is exactly monolithic.
Hempcrete touches the hempcrete.
Yeah, exactly. That's the principle, and
the roof and the wall, that's of course in this case stained and hempcrete.
yes, but exactly, but kind of the if I go back, in case of the roof, we went up with the hempcrete.
Yeah, the wall went up.
Exactly, upper, so you don't have this cold bridge. That's the so. So you see, as
Is
it
the cost higher in a building like this?
Economies of scale, not that much higher, and something I still have to do, but I have to kind of go through the entire kind of budget sort of point by point to actually see. But of course, the biggest cost is the import duties, really. And because we used imported hemp in this case, that was a big part of the cost. But in terms of, on the whole, No. So if you take, so we did like a basic calculation, and we kind of need to update it with kind of current prices. But if you take a cubic meter of concrete and you take a cubic meter of this material, they're more or less comparable at Icelandic prices and the prices that we got the hemp for.
What if it was produced here?
Exactly. That would make a difference, basically. And of course, the wages are high here, and it would be a question of automation and so on, and how efficient the sort of production element would be done. But it's not like a premium material. I think it has. If it became more expensive, then hopefully people would be interested in it, willing to kind of cover that for all the qualities that it has. But again, and the economies of scale, obviously, this is a tiny project. Once you have a bigger amount, everything goes down. Whether it's prefabricated or done in situ, so on and so forth. Then it kind of really comes down to the technique and the method of building a particular building. But yeah, long and short of it is it's more or less within the range. It's not much more expensive.
Do you know of other buildings using hempcrete in Iceland?
No, this is the only one at the moment. Yeah. So there is, with our partners, there is another project that's kind of in the pipeline in the Westfjords in Bolungarvík. That would be a kind of a real house in its own right. But at the moment, not yet. So kind of, we're hoping to do more, and also crucially also in a refurbished kind of application. So kind of, our hope is to demonstrate that it can, work well as an insulating material with existing buildings. And but at the moment, that's the one and only.
What about the machine?
Mm-hmm.
Right machine to work this material here in Iceland?
Yeah.
Is someone going to buy that or?
Well, yes, hopefully. And so there is like small scale machines. So there is a few people, 2 people that have 2 machines at the moment, but they are kind of small. And that's something that we will, as part of kind of an ongoing project, this will be more to do with analyzing what's the best way of retting and then sort of assessing the quality of the locally produced, locally grown hemp. But this is really something that can be done at this or a slightly bigger scale. To do it kind of at a larger thing, you need, it's not quite a factory, but it's kind of like a machine that's 10 meters by 5 kind of thing, and then you can produce it in a bigger quantity, volume. Yes, but it is an investment. So that's that's a few million euros to start it off. But I think it's a journey. First we need to.
Because we talk a lot about this, but you feel like we are taking steps forward, or are we just always on the same spot?
No, I believe we are taking steps forward. By purely having this building, by going through this research, by building up the data. But I think the biggest obstacle or the biggest hurdle to overcome is the building regulations, basically, and how that can facilitate things like this. So, at the moment we can build it from imported material, but in order to do it locally, and this is where it really makes sense, where, the material is grown and produced locally, the building regulations need to be adjusted to allow that. And this is kind of going, this is under review at the moment, so we remain hopeful. So yes, kind of it's not a massive momentum, but it's inching in the right direction. But obviously, we need to, as a construction industry, we need to act fast because time is running out.
Do you know like algae and hemp have been used together?
Yes, so we are. They have been on a kind of a small scale, and we're actually doing some experiments with that as we speak, to see how it binds together. But yeah, so we're kind of doing that at the moment, but sort of being conscious that at the moment it would need to be sort of more an interior application, not a structural one as such, because of the fire, you know, and all the different properties that are crucial for building. But yeah, because that's again something that we have plenty of in Iceland.
Interesting.
Now, my English is not so good, but in Icelandic, we are talking about in Iceland viðhaldsfrí hús.
Maintenance free.
Yes, yes.
It is not. It don't work with this environmental rate houses.
No, but what house is really maintenance free? If you look at it, you know, and what house?
I'm always trying to sell it.
Exactly. But kind of if you look at, you know, the sort of modern maintenance-free houses, you know, anything breaks, it's so complicated that you need a specialist to bring it in. You've got, you know, so many layers.
As the first houses you shown us with the framework and the ham.
Yes.
Back in the days, these houses had maintenance every once in a year.
Yes, I mean those ones did, of course.
With lime and with the jar.
Exactly. But you know, if you have depending on the cladding. So, for instance, this can be used with aluminium cladding if you wanted to. You know, it's more the kind of principle. So, like in our projects, yes, we're sort of intentionally or on purpose being, you know, quite low tech, and where of course, you know, you would need to maintain it, maybe not every year, but regularly. You know, depending on the type of the cladding, depending on, you know, the exact setting and how close it is to the sea and so on, you know, a hempcrete building can look like any other building. That's the point. It's more kind of the principle and what kind of sits within the walls. So again, internally with us here, it's kind of a rough look. That's on purpose. But if you use a vapor open finishing board internally, you know, it would look like any other building, basically.
And there's no, like, it's only, like you say, it's just the design of the cladding or something regarding having the studs on the, like, inside embedded in the wall or like on
Yes.
the right side.
Exactly. There's just kind of the planning, yeah. And
so you would be able to, but you wouldn't put cladding on the right side because you don't have the studs to it.
No, not in this case, but you
Or
could.
is it like, can you screw in it?
You can screw in it, yeah, you could, but then basically, so like one way, because it's quite a stretchy material, so, you know, if it's something light, then you can, you know, you just hang it normally, but yeah, exactly. But if you wanted, like, you know, something like a cupboard or like cladding, then the other way to do it would be to drive wedges, basically, like timber wedges, and hammer them in, and because it's stretchy material, it kind of pushes out, and then it gets stuck, and then you can fit whatever. Yeah, so kind of, you know, in a kind of prefabricated scenario, yeah, you know, it could be quite adaptable as to what it is. But like with any building components, you know, things are designed to whatever they're meant to do, basically.
When will there be an open house?
So, very good question. This summer, that's the plan. We haven't kind of set a date, but yeah, hopefully, kind of second part of the summer, once we finish the render on the outside, is the plan.
Okay.
Yeah. So definitely spread the word when things are in place, because it is really also about experiencing it yourself, and it is a different feel, you know. And like we're laughing with the Van der Gazelle that, you know, the kind of actual Bústath, where this is located, you know, it's like a standard thing from the early noughties, early 2000s, and you know, they said, like, you know, you enter the building and you smell how it's, you know, what's in there, and whether it's plastics and whatever. Like, you enter this, it's a totally different kind of experience. You're taken away from, you know, not considering the acoustic and whatever, just the feeling of it. And yeah, so like we had people coming over and they'd be like, yeah, it'll be amazing, you know, sound engineering studio, sound production studio. Yeah, there is, reason to see it for yourself. Put it that way.
I think is like the most economical, best way forward. Do you think it's in the in situ or isn't it prefabricated?
I would say prefabricated in Iceland, because
Probably gonna be the best way.
Yeah, just because of the weather and sort of unpredictability that comes with it, as well as kind of the drying time. Just because it's not a very humid place, but it's not a very warm place. So as we know, so I think, and obviously then the appeal really comes in terms of, like the popularity of COT sort of panel building comes in like Lego. The same thing can be done with that, and then kind of the economies of scale and the efficiency kind of kicks in. So I believe that would be probably the way forward.
Do you think it would be better if it was prefabricated in a workshop and then delivered to sites?
Yeah, I mean, I think
Time is already wasted.
Like, it is, unless you want to have fun and build it yourself. That's that's the other bit. Yes. Yes. Exactly. I mean, that said, like the spraying elements, that would be also interesting to see how that would kind of work here, and so typically, like Graham, the man who kind of specializes in this in Britain, he said, you have a single-family home with a sort of 3-person crew. Hopefully, I'm remembering this right. It would take about 6 weeks with a in situ. With the spraying methods, you would cut the time by half or something like that. Yeah.
I visited a house in Denmark that was made of concrete, but it's more like a garage type house. And then it was just a guy experimenting with it, and all 4 walls were made with different methods. So
Okay.
One wall was blocks.
Yeah.
One wall was in situ, and the third one was sprayed.
Okay.
So he was making like experiments on something.
Yeah.
And then it was talking about like how fast it was spraying it, but it was more of a technique thing, getting the pressure in the water right.
Mm-hmm. Exactly.
The block was kind of masonry style.
Yeah. And again, exactly. I mean, and it's kind of also the look. So like with this, with the in situ, you get this kind of smooth, you see the material for itself. When you have blocks, obviously you would see the elements. So then you can mix. I mean, it's all.
Like really, I really like the look of the in situ. Like you can see where.
Yes.
Where the layers.
Exactly. It's beautiful. Exactly. And yeah.
It's like cutting into it.
Exactly. Yeah. It's got this geologic sort of element. Totally. And obviously the other thing is, the type of mixer, the type of binder that is used as well. So we are, kind of keen to.
Always lime.
No, at the moment it is always lime, but like what they use in Germany when they use quick lime, the hot stuff, and then it dries much quicker. So I do wonder, like, we want to follow that up in terms of how it compares, in terms of the.
They've added something to the lime?
No, it's just it's not hydrated. It's a different process. So it's kind of more a rawer form of lime, and then it binds much faster. Whereas it takes slower to bind. So it's advantages, but you need to act quicker.
You said when working with lime, you need to use gloves and masks.
Yes.
Yeah.
So
Because of
Burns your skin.
yeah, kind of.
your skin. Yeah, okay.
It does, yeah. Kind of, especially if you do a lot of it, then you kind of, it's abrasive. Then you and typically you would sort of use vinegar to wash your hands after applying. So kind of, it's not super dangerous, but it's just it's irritating basically.
What are they doing with the Icelandic production today?
The Icelandic, I mean, there is none.
There is
No. So it's like just few people have grown hemp, kind of, on their fields and been experimenting with it. There's a few people, or particularly one person in the East who is kind of experimenting with it, but there is no production yet. And again, coming back to this all comes down to policies and building regulations.
But it can be used in other, like for clothes and
Yes.
things. So
Absolutely. I mean, this is the thing, that it's got, enormous potential. You take Hampidian, they used to use, now they use plastic, they used to use hemp back in the day, so you can make ropes out of it. You can, the textile industry is very interested in it because it's got, you create high quality, fabric out of it. There is a saying that the jeans originally used to be hemp back in the day. So there's endless applications that can be done. And that's also part of our hope sort of, with the next stage of this project to sort of demonstrate that it can really work, but to actually have the data, because at the moment it's just like, yes, it grows well, and there is no sort of substantive evidence yet, basically.
Is it industrial hemp that they are growing in the east?
Yes. Yeah. So all, like that's kind of what's legal. So it's got like.
But you still get the CBD oil stuff in it.
Yeah, you get a CBD, but you don't have THC, and it has like less than 0.02 or whatever it is.
CBD is also like a big.
That's another big, yeah.
There are lots of variations of plants
Yeah.
that people grow for.
Yeah.
Exactly, and there's different types of plants. Like different subspecies, basically, or the strains. So kind of like the ones that are useful for this are the ones that, they have less flowers and bigger stems, because it's the stems that produce the fibers and the sheave, basically. But there's also tea. You can drink tea out of it. You can buy it in Kronan. Very expensive. But yeah. Yeah.
How much of the plant do you use? So you use the stem for the materials, but what about the leaves?
So the leaves, the leaves are kind of discarded, unless you want to make tea out of them. But then the fibers, then that's all the, it's this stuff, it's fabrics, it can be used used together with bioplastics and in combination with other materials, and that's really the valuable bit. Yeah, basically.
Did you make any experiments with not other binders, but add to it like ash or something?
That's also part of what we are doing. Not for the project. Kind of like this was on purpose, just using a tested method that's has been built with in Britain in this case. But that's kind of what we're doing now in parallel, seeing what can be done. Exactly, ash, basalt, so on and so forth. Because ideally, going back to the beginning of my talk is like, how do we become as self-sufficient as possible on this island? Yeah, and what can be done? And there's, so kind of it can be used with clay as well. So that's been proven to work quite well.
Not much clay in Iceland.
No, you would be surprised. There is actually a lot of clay. It's just not really. It's kind of. So we met with a ceramist recently, and she explained like how it was up until the 70s basically that there was a ceramic industry here, but then for various different reasons it became much more profitable and made more sense at that time to start importing from Denmark. And as a result, this whole industry and this knowledge kind of went down, and this knowledge went down to the graves of a lot of people, that they kept their kind of secrets and recipes and so on. But there is a lot of clay deposits in Iceland. You'll be surprised. So, there you go. There's those. But again, it's a resource-rich island as well. We just forget about it sometimes.